Good afternoon, everyone. It's the time of the day where we have to learn on arguably the best subject of the world, the best subject rather in the world. Yes, so today we are going to continue from what we did yesterday. Yesterday we looked at indices and we were able to explain what indices is. I use the concept of a big guy and a small guy at the top. And then we also talked about the laws of indices. We talked about the multiplication law. We talked about the division law. We talked about the zero index, that anything raised to the power of zero, it's one, except zero itself. If it's zero is raised to the power of zero, it's not zero, it's undefined in that case. Then we also talked about the um, power law, where you have what a power outside affecting what you have inside. Then we moved on to talk about the product power law. The power outside affects every other power inside. That's the product power law. Then we talked about the fractional index, where your denominator becomes your root and your numerator becomes your power. That was for the fractional index. About the distribution law, right? Quickly, we said in distribution law, you can have something like this, all raised to the power of n. In this case, their bases are different. So this becomes a power n multiplied by b power n, inverse law. So if I had a over b all to the power of minus x, this would be equal to b over a all to the power of x. So these were the things that we discussed about in the previous class. So for today, we are going to solve typical JAM questions on English. Now, the very first question we are going to solve is this. We have to simplify the following, and the very first one we are going to solve is this. And we'll see this is why I said go through those laws. When you go through those laws now, it becomes a part of you. If you look at this now, it has something to do with the last law we talked about, which is the inverse law, right? Because you have a fraction, and the fraction as a power has a negative sign. So what do we do? To take away the negative sign, this becomes inverse of it, and that would now be 81 over 16 all to the power of 3 over 4. Now we can now go further by using the fractional and by using the product power law, so that this power is affecting 81 and 16. So I'll be having 81 to the power of 3 over 4 all over 16 to the power of 3 upon 4. If I move further, this now will give me 81 to the power of 3 over 4. I will use another law which is called the root law. Use another law which is called the fractional index law, right? So this would now be the fourth root of 81 all to the power of 3 all over the fourth root of 16 or also to the power of 3. The fourth root of 81 means look for a number you multiply 3 times to get 81. That number is 3. 3 times 3, 9. 9 times 3, 27. 27 times 3, 81. So that number is 3. Then 3 to the power of 3 is still 27. Will give us 27 rather. All over the fourth root of 16. A number you multiply 4 times to get 16. That's 2. So 2 to the power of 3 is 8. And I can leave it that way as my answer, or simply put it in an improper fraction. Then number 2. Okay, now when you look at the second law and the second question rather, how do we go about this? One, we can apply multiplication law here, right? But we cannot start applying the multiplication law, because in multiplication law, their bases must be equal. So if that be the case, what I have to do is express 4 and 8 in their base of 2. 4 can be written as 2 power 2. That 2 multiplies n here becomes 2n. Multiplied by 8 can be written as 2 power 3. So I have 2 power 3. 3 will multiply all of the powers. 3 times n, 3n. 3 times 1, 3. Then divided by, it remains the way it is, 3n plus 1. So to make it, now we can now apply the laws. What does the law say? This and this. I can start off with this first. Simplify this before I move to this. I will now have here 2 to the power of 2n plus 3n plus 3 divided by 2 to the power of 3n plus 1. Now, if I continue further, 2n plus this will give us 5n. So I have here 2 to the power of 5n plus 3 divided by 2 to the power of 3n plus 1. What do I do next? I can now apply the division law, which would now be that this will become 2 to the power of 5n plus 3. But be very careful, because I'm putting a minus, I'll put a bracket because it's affecting the signs that are inside. Okay, I think I should do it here where to be clear. So I should be having 2 to the power of 5n plus 3 minus into a bracket 3n plus 1. And then that would now give us 5n here plus 3. Minus affect this, I have minus 3n, and then here minus 1, which would now be 5n minus 3n will give us 2n. Minus plus 3 minus 1 will give us plus 2, and that's my final answer. Okay, I have this answer number 3 question. It says 2 to the power of x plus 3 plus 2 to the power of x plus 2 all over 2 to the power of x plus 2 minus 2 to the power of x. Yeah, very interesting question. Why? Because there's no multiplication and there's no division of their bases, except the all over we have here. But in that solving this directly, there's no multiplication and no division. So when you have this type of question, a secret is this: factorize them. Yes, anytime you see this type of questions, just factorize them. That's the secret. So how do we go about this now? This is what we are going to do. Let me start with the numerator. Yes, to make it easier. So I start with the numerator. The numerator can be written this way: dot 2 power 3 plus 2 power x dot 2 power 2. Now let me explain why it is so. This is the reason. The dot is multiplication, please. So if I put my multiplication, I'll be having 2 to the power of x. Their bases are the same. I can add them up. It will give me back this. Same thing is applicable here. Now, having done that, I can now ask myself, what is here that is also here? That's factorization. You group what is common. So 2 to the power of x obviously is common. If you divide this thing, let me show you how the division is done. Multiply by 2 power 3 all over 2 power x. So it's like saying this cancel out this. I'm left there with what? 2 power 3. If I do the same thing here, I'll be left with plus. It will give us 2 power 2. This is my numerator. My numerator can still be simplified for, or let me leave it that way as my numerator. Now let me go to the denominator. Now for the denominator, this is what I will have. I will have 2 power x dot 2 power 2 then minus 2 power x. The same thing is common, 2 power x. And I'll be left with 2 power 2 minus 1. Because when this divides, it's 1. So I can write them out now. This is my numerator, 2 power x into 2 power 3. Or 2 power 3 will give us 8. So let's be simplifying it. 2 power 3 will give us 8 plus 2 power 2 will give us 4. All over here will be 2 power x. And here will be 2 power 2 is 4 minus 1. This can cancel out this. But please, I've seen students perform magic. You now say 4 cancel 4. Please don't make that mistake. Somebody can ask, but why did this cancel this? Note, this and this thing is multiplying this. This is multiplying this. So when they are multiplying and there's a division sign here, you can cancel out. But in this case, they are to be subtracted and to be added. There's no how you can cancel that. If you do that, that's wrong. So 8 plus 4 will give us 12. And 4 minus 1 will give us 3. 3 here, 1, 3 here, 8, 4. So our answer is 4. Thank you. Then the last one we are going to solve, and then I will just give you one simple question. Yeah, one simple question to solve and try it on your own. So the last one we are going to solve is this. It says, so a to the power of 12, b to the power of 9, all to the power of 1 over 3. What law? Product power law, power of power. That would now be a to the power of 12 multiplied by 1 over 3, and dot b to the power of 9 multiplied by 1 over 3. 3 here it's 1, 3 here it's 4. So I'm left with a power 4, 3 here 1, 3 here 3. I'm left with b power 3. Simple. And even close your eyes and solve it. It's as simple as that. So the one I'm going to give us to solve, just try this particular one. Yeah, 3 to the power of n plus 1 minus 3 to the power of n all over 3 to the power n minus 3 to the power of n minus 1. I want to beg us something. We've come to today's class, and that's the end. We've come to the end of today's class. Plead with you that if you have questions, reach out to me. You can DM me or put your question on my comment section, and I will definitely attend to you. So please try as much as possible to study these things, and they are not difficult to learn. Maths is unarguably the best subject in the world. Thank you, and do have a lovely day.